Good morning, students. So in the last class we were discussing about the Fourier transform and Fourier's inverse transform, and of course we know from changing from one domain to another domain, for example time domain to frequency domain or frequency domain to time domain, we'll have to use some integrals. So these integrals will transform from one domain to another domain. So this is what in terms of sine and cosine. So this is what the Fourier transform does. And of course any waveform that can be converted into sine and cosine series, so Fourier series, and this will be very useful, especially in higher mathematics and in quantum mechanics too. So today in this class we will have some more ideas on Fourier transform, which is nothing but Fourier sine transform. So Fourier sine transform and Fourier cosine transform. So the integral will contain sine and cosine terms. So in the last video lecture, without sine and cosine term, but in this video lecture we are going to have sine and cosine term inside. So what we call this as Fourier sine transform and Fourier cosine transform. So there are two formulae which we will have to learn. The first formula goes like this. So Fs stands for Fourier sine transform. We are going to transform f of x. What we are going to do is Fourier transform in terms of sine. So Fourier sine transform of f of x equals, is it okay? Fourier sine transform of f of x equals, the formula goes root of 2 divided by pi f of x sin x dx. See here, sin x dx. And the inverse Fourier sine transform, which is given as your f of x equals root of 2 divided by pi 0 to infinity f of s. In the last video lecture we are discussing about minus into plus infinity. Can you remember? Look at the difference. Here it is 0 to infinity. So you have to remember the limits too. So f of s, the Fourier transform of f of x sin x sin sx ds. So this is inverse Fourier transform. This is ordinary one. Ordinary Fourier sine transform. This is inverse Fourier sine transform. Similarly, we can go for the cosine term. So Fourier cosine transform. See here FC. FC stands for Fourier cosine transform. So FC of f of x. Fourier cosine transform of f of x is given by this formula, and inverse Fourier cosine transform is given by this formula. So we are going to use these two, all the four formulae into some problems. We will solve some problems. Find the Fourier cosine transform of f of x equals e power minus alpha x. So Fourier cosine transform. So we have to use only Fourier cosine transform formula. Okay. So FC, the Fourier cosine transform of f of x is given as this formula. F of x is given as e power minus alpha x. Okay. So we have instead of f of x, we have e power minus alpha x cos x dx. Is it okay? E power, see, instead of f of x you substitute e power minus alpha x cos x dx. Is it okay? See here, instead of f of x we are going to substitute e power minus alpha x here. You know the formula, this formula you have to learn by heart. Throughout these problems, this formula is very important. Throughout this Fourier sine and cosine transform. So this formula you have to learn by heart. E power ax cos bx dx is given as e power ax divided by a square plus b square a cos bx plus b sin bx. This formula. Now here just you replace a by minus a and b as s. Okay. So in this formula you replace a by minus a. So this here e power minus a and b by s. See here, you can compare. So now this formula goes like this. So we have now instead of e power, see, integration of e power ax cos bx. So integration of e power minus ax cos s x dx. See here. So we'll have to replace this with a suitable a equals minus a, b as s. So this formula will go like this. Is it okay? See here. You have instead of a you will have minus a, instead of b you will have s. See here, a becomes minus a, and this is standard integral. Standard integral, the answer for standard integral is given by right hand side. Now what is the limit? 0 to infinity. So 0 to infinity. Now I have written the same thing here. Now let us solve. It's very simple idea. Now first we will substitute the upper limit first. So we are going to substitute the upper limit e power minus infinity. That can be written as 1 divided by e power infinity. E power infinity is infinity. So 1 divided by infinity is 0. Is it okay? I repeat, e power minus infinity. You have to substitute first the upper limit. So the first term becomes e power minus infinity. 1 by e power infinity. E power infinity is infinity. So 1 by infinity, which is equal to 0. So when you are going to substitute the upper limit, the answer is 0. When you are going to substitute the lower limit, e power minus 0. 1 by e power 0, answer is 1. Is it okay? 1. Now you have to substitute for x, you have to substitute 0. So cos 0 is 1. Already one minus is there. But you have to substitute the lower limit. One more minus exists. So you have plus. Okay, plus a divided by a square plus a square. What is sine 0? Sine 0 is 0. Cos 0 is 1. So that's why the answer is a divided by a square plus a square. And we have Fourier cosine transform of e power minus ax is given as root of 2 divided by pi a divided by a square plus a square. So this is the answer. Simple one. Just 2 slides. Is it okay? Very simple problem. And now we will solve for the same problem, but we are going to have it sine transform. So Fourier sine transform of f of x equals e power minus ax. So Fourier sine transform of f of x equals root of 2 divided by pi 0 to infinity. This is the formula f of x sin x dx. We are going to have the same method. Instead of f of x, we are going to substitute e power minus ax. And what is the formula? And the formula is little bit different with a minus sign. See here, with a minus sign. So e power ax sin bx dx with the integration, that will give you e power ax by a square plus b square a sin bx minus b cos bx. Again you substitute a equals minus a, b as yes. Here you will get this answer. So a becomes minus a and your b becomes yes. The remaining term let it be, and limits also 0 to infinity. So as I have written the same thing here, e power minus alpha x divided by a square plus a square, and this term 0 to infinity. As usual, you will have to substitute the upper limit first. When you are going to substitute the upper limit, the answer will be 0. Very good. Then we are going to substitute the lower limit now. So lower limit, this becomes plus. Correct? Sin 0 is 0. What about cos? Cos 0 is 1. So you have minus. Already one minus for the lower sign. So answer will be plus. So s divided by a square plus a square. So the Fourier sine transform of e power minus ax is given as root of 2 divided by pi multiplied by s divided by a square plus a square. Simple problems. Any doubt? Now we will solve using these two answers, e power f of x equals e power minus ax. We are going to solve some difficult problem. So Fourier, again we are going to use only Fourier sine and cosine transform. Okay, but we are going to find out the answer for this using the answer in the previous video. Okay, previous one. Find the cosine and the sine transform of f of x equals e power minus ax. The same thing is given where a is greater than 0. Deduce that. We are going to find out this and this. It is little bit difficult problem. Okay, we are going to use the same formula, same answer from the previous one. So we are going to find out cos sx divided by s square plus a square ds. What is the answer? And second one is integration of s sin sx divided by s square plus a square ds. What is the answer? We are going to find out. Okay. Now we know already this. So in the previous problem we discussed about this Fourier cosine transform. Fourier cosine transform f of x is given as this e power minus ax cos s dx, and we obtained the answer as this. From the previous problem we have already obtained. Is it okay? Now we are going to use Fourier inverse cosine transform. So we are going to use inverse Fourier cosine transform, which is nothing but this. So f of x equals root of 2 by pi. Okay, this is your Fourier cosine. So Fourier cosine cos x dx. Already we know that the answer for this one will be a divided by s square plus a square. This is cos sx dx. Okay. Now root 2 by pi multiplied by root 2 pi will give me 2 by pi. Okay, so a divided by s square plus a square. Now cos x dx. See here, cos x dx. We have what is asked? Cos x by s square plus a square with integration is asked. So we have cos x sx integration ds divided by a square plus a square plus a square. You bring it to this side. Remaining term, you have a is there, 2 by pi is here, and e power minus ax is there. You bring it to this side, left hand side. So that will be 2 multiplied by a will be 2a. So divided by 2a. This pi divided by 2, so it will become pi divided by 2. So the answer for this one will be e power minus ax pi by 2a. Is it okay? See what is asked? This one is asked. We have found out using inverse Fourier cosine transform. Is it okay? So this is the answer. Simple one. Now we will go for now sine transform. So for the second one, this is the second one. Here this is the first one, and first one goes with cos. That's why we used only cos transformation, Fourier cos transformation, and this will be Fourier sine transformation. So sine transformation. So sine transform. So Fourier sine transform f of x is given by this. Your f of x is given as in the problem e power minus ax, and we have already found out this value, which is nothing but s divided by s square plus a square. So we know already this. Now we will have to use Fourier inverse Fourier sine transform. So which is given as this. Instead of f of s, yes, we know already this answer. So we are going to substitute, instead of this we are going to substitute this. Okay, what is asked? Sine sx by s sine sx by s square plus a square is asked. So you keep all those things, the remaining term you pull it here to the left hand side. So that will be your pi divided by 2 multiplied by e power minus ax. Here pi divided by 2 e power minus ax. Remaining term and all here. So this is what asked. See here, this is what asked. Integration 0 to infinity s sine sx by s square plus a square ds was asked. Okay. So we have found out this one too. Any doubt? We have used the previous problem and we have solved this problem. Now we will go for find the Fourier cosine transform of f of x is given as 5 e power minus 2x plus 2 e power minus 5x. Okay. So Fourier cosine transform is asked. So we have to use only the formula related to Fourier cosine transform. So which is nothing but fc of f of x. Fourier transform, cosine transform of f of x is given by this formula. We know already this formula. What is f of x? Is given as this. So instead of f of x you can substitute here, which is equal to root of 2 by pi. F of x is nothing but this cos sx dx. Now we can separately you can write, very easier one. You can write separately. See, I have written separately and I can integrate easily. So I have written like this. I have pulled the constants out, 5 out. Here also I have pulled 2 out. So it's easier to integrate now. E power minus 2x cos sx dx. We are going to integrate this. So after integration you will get the answer. See here, e power minus 2x cos sx dx. What is the formula that we have used? Can you remember? Which formula we already studied in previous video lectures? Now here, see here, e power minus 2x cos s dx. We have integrated. What is the formula that we have used? Can you remember? E power minus 2x cos x dx. The same thing. Fourier cosine formula, cosine integral formula. E power minus 2x divided by a square. So a square is minus 2 square plus a square and this one. Similarly plus, and here it is. Here also we have used the Fourier cosine transform. So we have used this formula. So your a becomes minus 5. Here a becomes minus 2. Is it okay? Now you substitute the upper limit. As usual, e power minus infinity, that will go with 0. We will have to substitute the lower limit. Cos 0 is 1. Cos 0 is 1. We have minus 1 is there. Already lower sign, we will have to put another minus sign. So plus, you will get plus 2 divided by 4 plus s square. Similarly, you can substitute the upper limit, that will give you 0. The lower limit, that will give you minus 5. So minus of minus 5 will give you plus 5. So 2 times pi divided by 25 plus a square. After simplifying, you will get this. After simplifying, you will get this. So this is what I said. See, we have used this formula. Can you remember this formula? So this is what I said. So we have used this formula. We studied just the previous previous problems. So now 5 multiplied by 2 and 2 multiplied by 5 will give you this. Taking common term 10 out. So that will be the final answer. Okay, that is the final answer. Any doubt? So this is the Fourier cosine transform of f 5 e power minus 2x plus 2 e power minus 5x. So this is the answer. Simple one. Now we'll go for find the Fourier sine transform of f of x equals e power minus ax. So this problem is very, very important, and we are going to show that this is equivalent to this. This problem is very important. We will be using all the techniques whatever we have learnt earlier. Find the Fourier sine transform of f of x equals e power minus ax. Already we discussed already. We are going to use the answer for this. In addition to that, we are going to show that this is equivalent to this. We are going to show. So of course we know that the Fourier sine transform of f of x is given by this formula. We know already. F of x is given as e power minus ax. You substitute e power minus ax. We will have to use the formula which you have learnt in the previous problems. So we will have to use this formula. Can you remember? For sine it is minus and for cos it will be plus. So you will have to use this formula. Okay, you will have to substitute for a, you will have to substitute minus a and b as s. So a as minus a, b as s. You substitute, you will get the answer. So this is standard integral. Standard integral. So we will get the answer as this, and you will have to substitute the upper limit and lower limit. So that will give you 0, and sine 0 is 0, cos 0 is 1. Okay, minus that will give you 1 minus exists. So we will get the answer as plus s. This minus, see, cos 0 is 1 and already 1 minus is there. For lower limit we will have to substitute 1 minus sign. So that will become minus plus. The answer will be root of 2 by pi s divided by a square plus a square. So this is the answer. But in addition to that, we will have to find out show that. Okay, we will have to find out show that this one. Okay, this is the ordinary one which you have learnt already from the previous problems. Okay, now we will have to use inverse Fourier sine transform. So f of x is given as root of 2 divided by pi the Fourier transform of f of x sin sx ds. So we know the answer for this, which is given as this. Up to this we know already. Now you pull this one, you multiply this one and pull it out. So that will give you 2 divided by pi. I can write this as s sin sx divided by a square plus s square ds. Now you put x equals m, because in the problem it is given as, see here, in the problem it is in terms of m. So you just put x equals m. So this becomes s sin sm divided by a square plus s square. So of course ds. Now you just keep s as x, and when you are going to differentiate, this becomes ds equals dx. And instead of s, you substitute x. So you will get x sin sm, so mx, instead of ds, dx. Correct? Is it okay? Now what about okay, now you will have to find out only this one. Okay, what about left hand side? You can pull this 2 divided by pi to this side. So that's a mistake here. I repeat, see here, this is what it is asked. This is what it is asked. So integration of, instead of s, x sin mx divided by a square plus s square, you pull 2 divided by pi to this side. So that will become pi by 2 e power am. So in the earlier, see here, it is given as this one alone is, we will have to show pi by 2 e power minus am. This one, you just remember this one. See here, so instead of this you are going to write remaining terms, and extra 2 divided by pi is there. Okay, this you will have to bring to this side. So that will give you pi divided by 2. So pi divided by 2 e power minus am. So this answer is nothing but pi by 2 e power minus am. So this is the second one. This is asked. which is equal to pi by 2 e power minus am. Okay. Now find the Fourier cosine transform of f of x equals e power minus ax, similar to the previous problem, and here it is asked us in terms of cosine, cos. Earlier it was in terms of sine, now it is in terms of cos. So 0 to infinity cos mx divided by x square plus a square dx. We are going to prove that pi divided by 2a e power minus am. The same procedure. Your Fourier transform of cosine Fourier transform of f of x is given by this formula. Instead of f of x, you have to substitute e power minus ax and use the formula. As I said, for cos it will be plus, sine for it will be minus, as I said earlier. Then you have to replace a by minus a by minus a, and b as s. And of course we know this one, and as we discussed earlier, 1 by e power infinity, 1 by infinity is 0 and e power 0 is 1, we know already. Okay, so after substituting the standard integral, you will get the answer as this. You will have to substitute the upper limit first and lower limit next, and you will get the answer exactly like this, which we have already seen earlier. So no problem at all. So we have the Fourier cosine transform of e power minus ax is given as this answer. Now we will have to use inverse Fourier's sine transform. We will have to use inverse Fourier's sine transform to get the answer. So we will have to use this formula, and we have already found out this. See, we have already found out this. You substitute here, you substitute here, you will get this. Okay, now the same procedure. Your x, just substitute x equals m, so that will give you 2 divided by pi a cos sm divided by a square plus a square ds. You substitute s equals x, ds equals dx. You substitute here, you will get a cos mx divided by a square plus x square dx. Now this is what asked. The remaining term will be pi divided by 2a. So this is what asked. See, cos mx divided by a square plus x square integration dx was asked. See here, cos integration of cos mx divided by x square plus a square is asked. So you will get the remaining term. You pull the remaining term to left hand side, you will have pi divided by 2a. You bring this 2a also, so 2a e power minus am. Any doubt? So similar problems are very, very important. We have solved so many problems related to sine and cosine of Fourier transforms. Okay. Now we will go for find the Fourier cosine transform of f of x equals in this interval. So f of x is given as x when x lies between 0 and 1, and 2 minus x when x lies between 1 and 2, and 0 x is greater than or equal to 2. So 3 conditions are given. So find the Fourier cosine transform. It is asked Fourier cosine transform. So we will have to use only Fourier cosine transform formula, which is given as this. Now interval is given as 3. There are 3 intervals. So we will have to break into 3 integrations. 3 intervals are given. We will have to break all those things into 3 integrals. The first integral is f of x is nothing but x. See, x. Remaining term, your cos x dx is the remaining term, plus your f of x is nothing but 2 minus x. So 2 minus x. Your next one is f of x equals 0. So I have written 0 here. So now there are 3 integrals. The last one will go off because of 0. Now we are going to solve 2 integrals. First 2 integrals. Between these 2 integrals, between these 2 limits 0 and 1, 1 and 2. So you have, see, limits 0 to 1. Here limits is nothing but 1 to 2. Any doubt here? Now see, look at here x cos sx dx. So immediately you will get the answer as this. Which formula we have used? Can you remember this? u dv equals very good. This is, what is this formula called? Bernoulli's formula. Can you remember Bernoulli's formula, which we used long before, okay, to our video lectures before. So integration of u dv equals uv minus u dash v. So this is your differentiation. This will be your integration. Bernoulli's theorem. Okay, Bernoulli's formula, not Bernoulli's theorem, Bernoulli's formula. So Bernoulli's theorem will come only in physics. Okay, so Bernoulli's formula. So now you will have to write x as it is. This you are going to consider as dv. So here see u dv. This you are going to consider as dv. Integrating dv equals cos sx dx. After integrating, you will get v. You will have to substitute here. So integration of this will give you sine sx divided by s. See here, the formula goes like this: u dv equals uv. This is your dv. After integration, will give you v. Okay, so that will become sine. This is x as it is. X is nothing but u. See, x is nothing but u. So x sine sx divided by s. Then what is here? It is minus is here. So minus u dash. Answer will be, what is the differentiation of x? 1. See 1. Then what is the differentiation of sine sx? So cos sx divided by s, already one s is there. Integration. Minus sine sx. Integration, not differentiation. So sine sx by s will have to integrate. So that will give minus cos sx by s. Already one s is there. So this will become s square. Minus minus plus, that will give you cos sx by s square. Is it okay? Is it okay? Now limits 0 to 1. Similarly, we will go for the next one. I repeat, for this one is very simpler one. So as usual, this will be as u. So u will be your 2 minus x, and total thing will be your dv. So dv equals, this one means v equals sine sx by s. See, sine sx by s. 2 minus x. And what is the next one? Next one is minus. We have written minus sign. So 2 minus x. What is the differentiation of this? Minus 1. So here minus 1 is there. What about integration of sine sx by s? That will give you, so cos sx by s. So already one s is there. We can write this as minus cos sx by s square. Now we will have to substitute the limits. And I am going to substitute the limit. So I have written the same thing. Yeah, doesn't matter. Now we are going to substitute the first limit. So this becomes 1 sine s divided by s. So when you are going to substitute this will become cos s divided by cos s divided by s square. See here, I am going to substitute only for x, not s. X. This will become 1 sine s divided by s plus cos s divided by s squared. Now substitute the lower limit. This will become 0. This will become 1 divided by s squared. Is it okay? 1 divided by s squared. Is it okay? So you have 3 terms now. Cos s divided by s plus cos s divided by s squared minus 1 by s squared. Now you are going to substitute now for the second one. You substitute the upper limit first. So 2 minus 2, 0. So this term will become 0. Now you have to substitute here. So this will become cos 2s divided by s squared. Okay. Then we will have to substitute now 1 here. 1 becomes 1 multiplied by sin s divided by s, and you are going to substitute here. That will become cos s divided by s squared with a minus sign. Already one minus sign is there, so that will become plus. So you have now minus cos 2s by s squared. See here, when you are going to substitute this one, this will become minus cos 2s by s squared minus sin s by s. I repeat, see here, this will become 0. The next one, next term I have written the next term here. Next term, see, this will become 0. 2 minus 2 is 0. I have substituted only this. So I have written here. For the one, we will have both the terms. See, we will have both the terms. Now, first term and this term will get cancelled. This is plus and this is minus. So I have cancelled out. Now I can write this as s squared. See here, I can write this as s squared. Cos s. Here also you have cos s. So I can write this as 2 cos s. Denominator is the same thing. So no need to worry about it. So you have remaining term. Minus I have pulled out. So 1 plus cos 2s. 1 plus cos 2s divided by s squared. I repeat, cos s plus cos s will give you 2 cos s. Minus you have pulled out 1 plus cos 2s divided by s squared. 1 plus cos 2s is formula goes like this. You have 2 cos squared s. 1 plus cos 2s nothing but 2 cos squared s. So remaining term I have written, let it be. Now I have pulled cos s out. So that will give me 2 cos s 1 minus cos s divided by s squared. Any doubt? That is the answer. This is the answer. So here find the Fourier cosine transform. We have used Fourier cosine transform. We have substituted the limits here and we have cancelled the last one because f of x equals 0. Then we have used Bernoulli's formula and we have substituted the upper limit and lower limits and we have simplified. We have got the answer. Very simple one. Now we will go for Fourier transform of Gaussian distribution function. Okay, Gaussian distribution function. Gaussian means it is like parabola. This is called a Gaussian one. Okay, it's a parabola. See, e power minus alpha x is exactly like this. This is called the disintegration formula. E power minus alpha x. E power minus x goes like this. E power plus x goes like this. And e power minus alpha x squared will be always in a parabola form. Okay, you should remember what we call this as normal distribution. Sometimes if it is like this normal distribution, or otherwise we will call this as Gaussian distribution. So you have to differentiate. Gaussian distribution means this will be always in terms of e power minus alpha x squared. Okay, it's symmetry about its center. See, it's symmetry about the center. E power minus alpha x squared, always we should think about only Gaussian function. Okay, now the Gaussian distribution is f of x equals e power minus ax squared. Here a is greater than 0. What is our aim? We are going to find out the Fourier transform of Gaussian distribution function. We are going to find out. We are going to find out the Fourier Gaussian distribution of the function, and the Gaussian distribution of function is given as e power minus ax squared or alpha x squared, doesn't matter. So Fourier transform of f of x equals, which is given as 1 divided by 2 pi, simple formula, where f of x e power I omega, this time I have written as omega instead of s. Both are the same. You will have to have two different domains. That you will have to remember. One is s, another one is x. Here we have taken as one is omega, another one is x. See, the Fourier transform, it itself defines that we will have to have two domains. So in the introduction I said about the time domain and the frequency domain. Can you remember? Time domain and frequency domain and vice versa. So there will be two domains. So here also we have two domains. One is omega, another one is x. So in the previous problems we discussed about s and x. So the s is one domain, x is another domain. Here omega is one domain and x is another domain.